Listeners. Hi, everyone. Okay, welcome to Tethys Geoscience Foundation's next webinar. This particular webinar, we have a special guest, Dr. Piper Vasicek. Dr. Vasicek is a visiting professor at Brigham Young University. She earned her PhD in computer science, specializing in AI and linguistics at BYU. Today, she'll be talking to us about AI literacy for geospatial and environmental scientists. Dr. Vasicek, do you want to add anything to that?
I think that's good.
Okay, well then I will turn the time over to you.
Okay, thank you so much. I'm really excited to be here. I guess I will add a little bit, but only in the sense so you know kind of where I'm coming from. So I'm in the linguistics department at BYU right now. I started in linguistics. As a undergraduate, got my bachelor's degree in linguistics, became a web developer, and then eventually came back to academics to get a PhD in computer science and didn't really expect to go back in the linguistics direction, except that I started doing my research for my PhD right around the time that large language models really started to take off. And so that made it possible to kind of tie those two things together, both the linguistics and computer science that I was really interested in. And so for this webinar today, what I really want to talk about is I want to start by talking about understanding um, what generative AI, specifically text-based generative AI is, and where it comes from, so that um, to give you kind of a foundation, a little bit of better foundation there, and then talk about some of the opportunities that has for research. Um, and I think it's really important for everyone to have some amount of understanding of what generative AI is doing, because everywhere these days you see headlines that uh, tout what generative AI is doing, what it means for the future. Um, uh, Often, it suggests that you might need to be worried about where we're going with this technology, which isn't entirely untrue. But when even people like the Google engineers themselves are telling you that AI is sentient, it's hard not to wonder what exactly is going on there. And I've been in this field long enough to remember the very first of these headlines, which was when OpenAI, who produces ChatGPT, originally produced a model that they were concerned would would be too dangerous or would potentially lead to misinformation and things like that, and so they didn't want to release it to the public. And you can see that one of the many news articles that was written about that up there. OpenAI built a text generator so good it's considered too dangerous to release. And this is really just the beginning of what continues to today with AI agents breaking out and hacking other websites. And what I feel like for these is really this is really good marketing. This Some of the things that are claimed aren't really being claimed by OpenAI even, but once the news gets a hold of it, these are the kind of things that make really good newspaper articles and therefore end up being really good marketing. And so what is generative AI down at the root? So in general, generative AI are machine learning models that use machine learning models that create original content of some kind. And like I said, we're specifically going to be talking about text generation. And as far as text generation is concerned, um, this is really, and you may have heard it before, that this is predictive text. And really, that is the case. If you kind of go look into it, it's predicting the next thing that should come up in the text. But it's dialed up to 11, right? And so, um, why is it that we have predictive text? Like, what is it about predicting text that makes it that is what kind of ultimately broke through kind of the whole problem of generating language. Well, a big part of this is because when you're teaching a machine to do anything, um, there are a few elements you need to be able to actually have the machine learn the task. So for anything that you want a machine to do, you need a well-defined task. You need the ability to evaluate the result that comes from that task. And then ultimately, you'll need lots of data or lots of compute power, and I should say lots of compute power. So for example, if we look at other things beyond language, if we look like, for example, at chess, um, the task is pretty well defined. You know exactly what the pieces on the board can do, and you know what the case is for winning. And so you can give a computer the ability to do any of those actions, and then you can evaluate the result. Did the machine win the game or did they lose the game? And because you can evaluate that result, then you can adjust the algorithm can adjust itself accordingly. The same is essentially true for even very, very complicated tasks like autonomous vehicles, right? So if you break it down to the if you break it way down, basically an autonomous vehicle, its task is to get from point A to point B, and then you can evaluate the result. Did it actually make it to point B? Did it run into a pedestrian? Like that would be a bad outcome, right? So there are result you can build in basically these ideas of how do we evaluate how well the algorithm performed. And also for both for well, especially for chess and things like this, you can produce your own data fairly easily. So this has been true for a while, that it's possible to have the algorithm even play against itself to create more data to be able to use. And this is a lot more difficult in a text environment or a language environment. And these things are true for kind of any subjective task. Well, if we look at the things that we talked about, we need a well-defined task. Um, if you try to think to yourself, how do I, what I need to write an essay, for example. Well, you could go back to kind of the high school definition of an essay, and we're talking about, maybe we're doing the 5-paragraph format and you have the intro paragraph. So there are some ways that you can break down this task further, but once you get into the nitty-gritty of things, what words actually go in there, and how do I know that um, how do I know if I wrote a good essay? So I could put a lot of words on a page um, easily, but how do I then evaluate that result? I can evaluate the result if I ask some English professors or someone who knows something about writing, but that takes now a lot of time and manpower to evaluate the result. And when you have tasks like this, these are things that you can teach machines to do, but in many ways, it's a lot more difficult. And what you end up needing is you need where we need lots of data and compute power before, this is even more so true on tasks that are much more subjective. So back to the idea of predictive text. So what did predictive text give us that other tasks in language don't have built in? Well, predictive text is very well defined. I want you to tell me what the next word is. Um, you know, it like I said, if you have a well-defined task, you can ultimately theoretically anyway, teach a machine to do it. And then the ability to evaluate the result. Did it provide the next word that you were looking for? Was it actually the word that was there or was it not? And adjust your algorithm as you go. And finally, as I said, with subjective tasks, you need lots and lots and lots of data. Well, predictive text gives us ridiculous amounts of data because every article on the internet, every blog post, every um, text message, any of these has a next word until you get to the end of the document, of course, but then you go on to the next document. So there's an entire internet worth of human provided data that has that predictive text available. And then the compute power came along at the right time. So there's some suggestion in that, it's been suggested before that one of the reasons that transformers, which are the current technology that large language models are built on, one of the reasons they took off was because they came onto the scene at a point when finally the compute power was actually there to do something interesting, and um, and I think that that's true. So now we have this task. We can evaluate it. We can give it lots of data and compute power, and finally we have something that can produce language. But one thing that we should note is that it's not just predictive text. What we really should say is that it's predictive data. And so rather than just predicting a next word, um, large language models have now been enabled to predict the next piece of data. Anything that can be represented on a computer using bytes can be produced by the computer. And what this means practically is that a computer can use tools now. So you can tell it, um, you know, historically, ChatGPT was very bad at math because if you just read a lot of books or you read, an internet worth of data, it's hard to just predict what the number is going to be from kind of whatever statistical correlations that you've learned and taught yourself. So you can get 2 + 2 = 4, but beyond that, you're going to start to struggle. But if you give it the ability to use a calculator, so instead of when it sees that there's numbers there that it's going to have to do some math, instead of trying to predict what that number is going to be from what is statistically available, it produces a next word or what we call a token that says use the calculator and give it this data and then give that back to me, and it can take that information and use it and give it to the user instead. So this is true for things like a calculator. We know that there's web search available. I mean, you've seen that if you've used any kind of um, chat engine, that there's the capability to do web search and things like this. You could even give it things like a chess engine. You could give it anything you could think of, access to another model that has the capability to produce an answer that it cannot produce on its own simply by being able to put words together. And this leads to another thing, or perhaps the biggest thing to think about and to be aware of when using large language models is that it's not just the model itself producing, language anymore. It's embedded in an entire system of embedded in an entire system. So we talked about tools already. It's been given access to tools. It also has hard-coded rules that are available to it. So um, I probably many of you are familiar with the how many R's in strawberry issue that ChatGPT had, where you could ask it how many R's were in strawberry, and it would tell you that there were 2 R's in strawberry. And no matter how many times you tried to convince it otherwise, it would continue to believe that there were 2 R's in strawberry. Well, one of the ways you can deal with this is by having your developers hard code rules in. So they say, if anybody asks you how many R's are in strawberry, don't, it's 2. Like, well, I'm going to tell you, or sorry, it's 3. Don't tell them it's 2. And I am fairly certain that this is what they did, at least for a time, because there was a time at which you could ask how many R's in strawberry and it would tell you there were 3. But if you asked how many stars or R's are in raspberry, it would tell you there were 2, only 2. And so they can patch individual things in the code by hard coding rules in. Almost certainly some of the times that a chatbot tells you that something violates their terms of service, so they can't show you the result. This is also probably related to hard-coded rules that are imposed from the outside. Other things that are part of this embedded system are things like memory. So um, they have developers have enabled chatbots to keep certain text that for whatever reason it thinks is useful in sort of a memory bank outside of the current chat that you're having so that it can pull that text in when it's performing, when you give it your prompt and ask it what to do, but it will also pull in this other information that is potentially useful and can inform the output that it will eventually make. And other things like the ability to revise output. So instead of just giving it a prompt and it outputs some text, a lot of times that text will be re-inputted into the model for editing purposes potentially. And it could be multiple times that it does that as well, which is why with a lot of the newer models, what you see, or it can take variable amounts of time for it to actually finish the result because of these various steps that it's doing with using tools, putting things back through the system, and things like that. It can also do things like produce multiple results. Now you've probably also seen this where you can choose, it'll ask you, do you like this result or this result better? That's for training purposes internally, but they do, to a certain extent, produce multiple results and feed all those back through the LLM and allow it to choose which pieces of each result it wants to use. So like I said, we're still basically under the hood doing this predictive text of what is the next thing and what is the next um, thing that we need to add to this. But it's now been augmented to have access to these various abilities, and and that will continue to grow, the things that it can do in that way. So what does this mean as far as how we as researchers can use LLMs for our research? So this is one of the a paper I worked on with some colleagues here at BYU that was in specifically the human computer interaction space, but looking over kind of the whole process of when you're doing human computer interaction research, at what stages in the process can you involve LLMs and to what degree? And so this is something that I've thought about as through from the nearly from the beginning of when this became a possibility. So thing number one to notice is you are never alone, or you are never alone, like in a good way, right? So what LLMs allow you to always have a brainstorm partner, and it's trained to be helpful. Which is in some ways a good thing. So if you have done some programming, or you may be aware of the rubber duck idea, which is programmers sometimes will have a rubber duck on their desk that they can describe the algorithm that they're building to the rubber duck, so that they have someone or something that can listen to their ideas, and it gives them something um, to work those ideas out with. Well, in this case, you also have something to do that. Now, in this case, now it can respond. It's not just a rubber duck. It can actually respond to your ideas. And this is both a good thing and a bad thing. So I said I would talk about the opportunities, but there are also pitfalls that you have to be aware of as you do these kind of things. So you always have a brainstorm partner. This is actually a really good thing. This is potentially good. But being trained to be helpful does not necessarily mean correct. So one of the things you have to be very careful of is because it's trained to be helpful. LLMs are often described as they can be sycophantic, meaning they will always tell you that your idea is the best idea they've ever heard. Now, you and I both know that all of your ideas are good ideas, but you shouldn't trust people who tell you that. Oh, sorry. Anyway, no, but yes, you need to be aware of when the system is telling you what you want to hear. And you may have to tell it not to do that. It won't always work, but it can be sometimes helpful to actually say, please, tell me what you like, tell me what you really think, or you should always push back on answers that AI gives you. That can be really helpful to coming to something that is actually realistic. And I'll continue to go into that because that is really a theme of using AI. for these kind of things. Second, I think that it's really useful to know that AI can point you in the right direction. So if you want to get a general idea of a new area that you're not familiar with, this is something that AI can most of the time be pretty good at. It can suggest reading material that can get you further than it can get you on its own. Um, AI is not an expert in any particular area, but it knows more than most people about most areas, if that makes sense. So you are an expert in whatever area it is that you're researching, and you probably, well, I hope that you know more than AI does about that area. You should. If you're an expert in the area, you should. Um, but if there's an area that you're stepping into that you are not familiar with, AI probably knows more than you. Um, Now you do have to figure out how to verify the things that it's telling you. You always should. But this has been true for a long time. So there is this idea from newspapers that, someone's reading the newspaper and they get to an article about a subject that they're familiar with and they read it and they're like, oh, this newspaper is garbage. It totally um, doesn't know what it's talking about in this particular area. But then they turn the page to the next article and accept it at face value that everything that's written is 100% correct. And and so uh but this is kind of like, yeah, but this is still a problem, and very much in the case of LLMs, because they can produce so much information so quickly, the ability um to curate that information or to verify that information uh, has to be something that you build into your process. Otherwise, you just have more information than you actually verify or can do anything with. Um, a specific example of where this particular thing can go wrong is the citation problem. I've also done some research in this area, and I feel like everyone has heard that like ChatGPT makes up citations. However, it continues to show up in the news, particularly like in the legal field. So I feel compelled to mention that LLMs will fabricate citations. And I also think it's important to know that this has actually become, in some ways, a bigger problem than it was previously, because fabricated citations have been published now in various journals and other places. I don't know to what extent this is true, but we all know that there's junk journals in various fields that will publish almost anything. And when you combine people who are either rushed, if we're being charitable, or are being dishonest, however you want to characterize it, there are people who have submitted papers with fabricated citations in them, and journals who, even if they have peer review, they haven't all been checked, and those citations have been published. And one of the things that, for example, Google Scholar does when it is trying to create its basically database of citations is it scrapes published works, or it pulls published works off of the internet, and it sees what they are citing, and it can create database entries for those citations. And so there are fabricated citations that now appear on Google Scholar as if they are real citations. Obviously, there's no PDF or anything like so like you can't. There's no link to get to it, or there's a broken link. But even just going to Google Scholar and seeing if it exists in their database is not necessarily good enough. Like you need to to be sure that a citation is real, you have to go through and read it. Which, of course, if you're citing it, you should obviously you should be doing that because you should have at least looked at as much of the paper as necessary. But if you're getting a citation for, say, you're pushing back like I've told you to on the LLM, and it gives you, oh, here's my citation, it may not be enough to just see if it shows up online, if that makes sense. Um, okay, so another thing that LLMs are very good at is quickly synthesizing large amounts of data. It can do this faster than you can. It can do this faster than your research partners can, or your entire lab can. It can synthesize large amounts of data. This can be really useful too. I know some people who use it to summarize papers. Like if you have a stack of papers that you are like, I someday want to get to these papers. It's a way that you can potentially summarize those papers and kind of get the gist of it, see which ones you maybe want to read more closely. This is a great use of AI. Um, it can also, there are also various tools that you can read papers with various AI augmentations. So, Semantic Scholar is an interesting one. It has some of the summarization features. It also has a feature that will highlight the text in various ways. So as you read through it, it will show you like here's main ideas, here's various things that you might be looking for in the paper. I think they might anyway. There's some really interesting augmentations that people have done with AI for reading papers in that way. Now, where you really want to be careful with this particular, like this is very positive. I actually think this is a really useful thing that AI can do for you. One of the things you want to be very aware of is that AI trends towards 10 to the average. So there is this interesting paper that has been discussed called Autonomous Language Image Generation Loops Converge to Generic Visual Motifs. What this means is they essentially gave a an image generation model a prompt and it made an image, and then they gave that image to a language model and the language model described the image, and then they gave that description to another image generation model and had it make an image. They gave that image back to the language model and so on and so forth for about 100 times. They did this loop and they found that they almost invariably ended up with some kind of, this is like, you probably can't tell in this image, but it's a room, kind of a palatial room, very stock art kind of image kind of thing. And this is what happened with all of these prompts ultimately was in this process was they became these sort of they called it the visual equivalent of elevator music. So kind of tends towards this average. And I have found this to be the case as well with some of my research that has involved analyzing human data. So one of my research partners does a lot with this idea of using AI to analyze interviews, which is a really large sticking point in especially in human computer interaction where you're talking to a lot of people. And so how her research interests have to do with can AI produce a good analysis of these interviews? And with my with the research that I've done in sort of in that area with her, um, it can give you analysis of things, but it's not necessarily going to be interesting things that it will give you back. It will give you sort of average things, maybe not the things that you're necessarily looking for when you're doing that kind of analysis. So this is just something to be aware of. And then finally, I kind of want to end on what I think is actually, well, I'm going to flip the script and we're going to do like the other direction. So I recently heard this quote and I thought it was a really good one. So the idea that AIs are better at code is garbage. AIs are better at code in an hour. Now, that with a caveat. So they went on to say that it depends if you can code or not. So if you are a programmer who has done a lot of programming, um, AI what AI produces it will not be better than what you produce ultimately, like in the course of a month, like as far as security features and so on and so forth. But what AI can produce in an hour is better than anyone can produce in an hour, no matter how good you are at programming. Um, and if you're a beginner at programming, AI will be better than what you can produce as a programmer. But if you don't want to become a computer programmer, if that is not your what you feel like your destiny is in life. The good news is that there's a low cost of failure for a lot of these things. I think one of the best things about AI is that it like allows you to experiment and to do it, as I said, with a low cost of failure. So I don't think obviously that we should be doing production grade things like having AI write entire research papers or things like that. But um, I would um, I highly recommend that you experiment with various ways that AI can be incorporated into your workflow, some of the ones that we've talked about, as well as other ones that you see and where it works for you. If you can verify the information, if you can find things that work, then absolutely use those. When my my husband is really interested in AI as well, and he's been telling me about AI chess. I'm not actually particularly interested in chess, but he is. And I guess apparently there are chess matches where it's AI plus human against AI plus human. Like these chess matches exist. And it turns out that AI with a human can beat AIs alone, apparently. This is hearsay, so I should probably verify this information. But AI will get better. It will be able to do things better. But I don't think we're on the horizon that it's going to know more than experts anytime soon. It's limited by the information that it has available, and I think it'll be and there may be breakthroughs obviously that come that will make it more creative and more able to do things that are beyond the average that push the envelope in language. But I don't think we're quite there yet. And so stay tuned. We'll see where that goes. Any questions?
Well, I have lots of questions. I think, honestly. Uh, so one of the things I know I've heard discussions is a lot is about the man in the loop concept. Well, actually, no, I have another question because you're in linguistics. How well do you think, since language drifts over time, how well are large language models keeping up with that? For example, I get stuff from engineers all around the world, and I think every engineer has their own language of how they talk about things. How well, I mean, part of that I can see if it's moving things towards the average, it's going to find the semantic average. This is how most people refer to it. But then that causes a risk that if you as a researcher are using terms that are very unique to your research, how well does it grasp that? How well does this large language models and other AI adapt to changes in language?
That's a good question. I think so. This is a little bit outside like my specific research area, but I would say poorly, at least as far as um, like you said, because it's an average type of thing. It probably will have trouble for with terms that are infrequent and that are used in like a very specific area. Despite the fact that it can tell the difference between a bank where you put money and a bank like a riverbank. You will run into problems if you ask it like, what is the definition of a more technical term in a very specific field, because it may confuse it with um, I, I I talked to someone who I don't know much about geoscience, but I know that chemistry and physics sometimes have similar terms that are also used in geoscience, but in a very different way. And so I have talked to someone who talked about how that they often found that that was a problem where it would give them a definition of a word, but it was usually in a different field than that one. And so you may be able to, if you're doing something like asking for a definition, if you specify the field that you're in, that may be helpful. But yeah, that's a tricky problem, and I don't think large language models have solved it.
I think I mean, I definitely have more, but I know you and I have talked about AI stuff before, so there's, uh, um, I think my original one too is the human in the loop is what I hear people talking about a lot right now. Is that for a lot of research, it's going to come down to, okay, where was the human who verified this? Where's that expert? What are your thoughts on that?
Human in the loop is really interesting. Human in the loop, some of my early research that I did with the research group I was working with was not necessarily with LLMs yet and was looking at human in the loop research where can we have humans verify this information, um, or enough of it that it's worthwhile. This is a big area in large language models right now, is how much do we need humans in the loop? What tasks can large language models do? And this it's very much in flux right now. So there's a lot of research lately that's talking about one of the things I'm interested in is annotation. So can large language models annotate data the way that a human would? And there's new research coming out all the time about how do we, is the large language model as good as a human at annotating? Or some things that people do are if you have two, you have two of your own human annotators, and then you use, well, it can go both ways. So you have your human annotators and use AI as a tie break, or the other way around, where you have multiple AIs that are annotating something, but you use a human to break ties as far as if they disagree. But that's still like all of these things are kind of the the new frontier of what, how do we actually verify with LLMs and things like that.
I've got a question.
Mhm.
Um, so I'm this is actually really fun timing because I'm using AI quite a bit this week to help with proposal writing. And a lot of what you report rings true. It's pretty good, I think, at aggregating and summarizing and doing things like that, which is a big part of the process that I'm going through. But it definitely needs correction and guidance along the way. So human in the loop for sure. Is there any measure of, I'm trying to think how to formulate, I guess, measure of how dependent or how much human in the loop is required of a particular AI engine? And is there, and if so, is there kind of a prediction of, how that will decrease over time, like how AI will become more independent? Does that make sense?
Oh, that's a really tough question. That's a lot of forecasting, and
Yeah.
yeah, that's a really tough question. Um
Or I
as
guess
it
how
stands,
far it's progressed
yeah, I mean,
since, initial LLM models became popular.
yeah, so it's tricky because we talk about hallucination in LLMs, and hallucination, if you're not familiar with the term, is essentially LLMs telling you something false. And there's lots of research right now about is it in the training data, or is it just something it's making up out of whole cloth, or is it something else going on? Categorizing those, but hallucination, we've named it now with LLMs, but this is something that goes to any machine learning model, um, because you're training on data and you're not giving it specific rules of how it should behave and programming it directly. For any kind of machine learning model, there has always been some amount of ability to go astray in strange ways that we don't understand. If you look back at autonomous driving, I haven't seen this as much anymore, but near kind of the beginning, you had the thing that was there where you could like put a random sticker on a stop sign, and the autonomous vehicle wouldn't recognize it as a stop sign anymore, just because it was weird things happen when you do machine learning in that way. So the other thing though about and this is why it's important partially to understand that we're looking at predictive text, is that it's not unlike chess, which you can easily evaluate in that it won or it lost. Predictive text is something different. And so honestly, for me, the fact that it works at all is sort of miraculous, because um, it doesn't work the same way. It's not as concrete of an objective that you're giving it. Because there is no, yes, there's a right answer for that specific text, but the thing that comes after the word the can be all sorts of different things in language. I think it will be a long time before model like and well, okay, I'll even be more direct. I think the LLMs as they exist today will not be able to be fully trusted the way that they're programmed at the moment. I think that there are things that may come in the future that will make that will upend that potentially, but I don't know what they are. So this is, unknown unknowns or maybe known unknowns. Um but um I do think that things will become more reliable. In fact, LLMs have, I think, become more reliable now that they have things like web search and other kind of search things like this, because instead of just predicting text, what this particular tool of web search allows them to do is you load a bunch of information in when you prompt them, and it can find the information in that text that it's loaded in, right? And so I think this is part of what's made LLM somewhat more reliable today, a big part of it. But how long it will take them to become like what that percentage is, um, or how long it will take them to become dependable is a really sticky subject. And I think that's one of the reasons that experimentation is so important is I think everything needs to be verified at this point. Um, but I also think that as you experiment, you get more of a handle on where you need to push back and what looks fishy to you and things like that. But I would at the moment, if you're going, especially like I said, if you're going to use in a production type of environment where you're going to send it out somewhere, I would check everything, and then it would be more like the degree to how far I would dig into it would be more of what I would um, like some things I can probably do a superficial Google search and see if they're correct, and others I might need to push a little further.
Interesting. Yeah, I think it definitely has gotten better, but like you said, I think it's because the AIs are able to use more tools that are deterministic, right? That are not, it's not making things up on the fly. I find when it's left to its own devices, it tends to, well, it definitely doesn't do as well.
Yeah, I agree with that.
Okay, I have one more question that I want to ask. So I was talking with a family member, and they were discussing one of the biggest things they're dealing with AI rules, and I know this will affect researchers, is that, he was talking about how like FARs and DFARs and some of the other defense contracting, decent defense, works, is having to update their policies on how AI is used and where it's allowed to be used. How much do you think governance is going to end up impacting AI and AI research in the future?
Can you just repeat the last sentence one more time just so I make sure I got it?
So how much do you think governance, because right now we're talking about governance coming in and saying, okay, you're allowed to use AI for this, but not for this. So in this case, he works for the government and they're just saying you're not allowed to use AI for certain tasks. And some of them he's wondering, it's like, this seems like a really simple, we could just have AI fill this in, That's kind of like the proposal writing that was mentioned. So that we can, how much do you think governance is going to be able to keep up with how AI is evolving? How is it going to impact things in the future? Because I'm certain it's going to impact a lot of us if, suddenly you're not allowed to use AI in this part of your proposal, you know.
Yeah. Yeah, that is a good question. And I for sure like being able to keep up, that's tricky. Government is not designed to keep up, right? That's, that's one of its, I don't know, it's one of its it's a feature and a bug, right? So like and it's meant to be I guess in that way. Um I think it will change. I think there will be a lot of change. And I think ultimately some things that are not accepted right now will ultimately be like accepted because they're like just improves our workflow, and so we're going to do it. But I do suspect that government will have very strict rules compared to anything in the public sector, as far as that goes.
Well, like the
Um,
EU has just stated that you have to declare, if a product was created by AI,
mhm.
and that just went through. So that's why I'm wondering things like that are going to impact our research and what we're doing.
Yeah, and I think for as far as the research goes, already like you were saying, like there's lots of places that like you already have to, there are statements that appear now of how did I use AI within this research. I think that that's worth disclosing whether it's required or not. Um, just because of where the tools are at, um, knowing what they did like is a useful data for people who are reading what you're doing. So I think that that's a good thing in its way. Um, but for sure, there's a lot of governance that's still working its way through the system, and it's been doing it for years now. So like all the things with copyright, those some of those results are starting to come back. But not all of them. There's still a lot to, as far as law goes, a lot that's still going on with AI and law. And I think um, it will get. I suspect governance will get harder before it gets softer on it again, if that makes sense. So I think you'll. I suspect that you'll see a lot more um, into the nitty-gritty details of what you can do. Is A, B, C, D, E, F, G are the only things you can do. Um, I suspect that that will eventually pull back again. Um, but one thing that I definitely encourage is everything. Well, and you should do this whether the things change or not. Is know how to do the things yourself as well. Um, I want you to experiment and learn to code, but while you're learning to code with AI, learn some of the things that it's doing so that you can start doing those checks of and verifying on your own, and read through everything it writes for you and make sure that it's saying what you meant it to say. Um, and I know that's less fun than just having it write things for you and you're done. But it will ultimately be to your benefit that you do things that the right way in the first place, and have good habits around how you, I don't know, you could almost call it AI hygiene. Good AI hygiene will and this is as much for me as anybody else, because it's so easy to do some of these things, but know how to do them. Read the things that it's writing for you. Make sure that it's saying what you want it to say.
Oh, and I have a follow-up question to that, if you have the time. Reproducibility. When you're working doing research with AI, does that make it more reproducible or does it make it more difficult to reproduce? I know I've
Okay,
given like, here's the prompt I used, and I handed the same prompt to somebody else and they get a different result.
yeah, that's a really good question. So, um, yeah, there are some things you could do for reproducibility. I probably should have had a slide for this, but one of the things is if you're going to use a model, don't use like the public-facing chat version of the model, um, because you can't get any information about what exactly, like which algorithm are they using, things like that. So use the actual, figure out how to use the actual model that you can send like API requests to or things like that. Um, so that's one thing. And that way you can report the actual algorithm that you're using or the version of the algorithm that you're using when you do your research. And uh, there is a measure. There are some, depending on the model, you can sometimes get a key or a number that will actually reproduce um, um, the exact output that you were able to use. Sometimes you can control that a little bit with something called temperature. If you put temperature to 0, that means the least change possible. Now, for most models, there is still some variability in that, but it reduces it a lot, the amount of randomness that's in the result that comes out. Um, and the other thing is to be aware of is we were talking about tool use. For some models, you can tell it which tools it's allowed to use, because you can imagine that if you put in a prompt and it's using web search, for example, that web search is going to change in 2 months, what it's potentially going to give you back. And so that can change your model, whether you put the same prompt in, whether you deal with the temperature, even if you put like a key in, that will affect the output. So those are things to be aware of as far as reproducibility goes.
Okay. So I think any other questions before we wrap up?
I have a question.
Yes.
Hi, I'm Reshma. Sorry, can you see me? Hi, hi. So I was just thinking back to what you said earlier about how we should still have people double checking what AI does, but I'm just trying to think like, is there really an incentive for humans to kind of maintain, any of the skills that are needed to do that? Because they're like, okay, AI can already perform these many cognitive tasks better than we can. So like, what is my incentive to actually learn and do things, the hard way? So is AI literacy about learning to use AI or about preserving enough human expertise that we can still recognize when AI is wrong? Sorry if there was just like a bunch of, hopefully I articulated that well. So just wondering what your thoughts were.
I really appreciate that question, actually. And I think that's actually of the things that I think are concerning, that may be the most concerning to me at the moment, at the state that we're in right now. And I think that's really to be seen in the future. And it's something that as individuals, I think at the moment at least, as individuals, we have to be aware of that problem and personally choose to do hard things, I think. And how this will shake out in society, I do not know. And I like I said, I think this is one of the most concerning eventualities of AI as it exists right now. But so like I said, personally, be very careful about, that you are continuing to learn and use the skills that you have, and that you don't, um, you know, I want you to use AI. I think it's really helpful, but yeah, be aware of that possibility. And then also for people that you are like that you are responsible for. So I think this includes your family and employees, things like that. Um, um, as you know, whatever the government has as its standards, your standards should probably be, you should also think about what your standards are in your workplace, with your lab, with the people that you, like I said, are responsible for. Because like it will ultimately harm them as well, like and society, and like at the bigger picture, like it goes out from there. So I think that that's a great question and really important, and we don't know yet.
Thanks. The last one that I just want to tack on, because I do want to mention this, like there's that recent incident where the OpenAI evaluation model escaped its sandbox and compromised Hugging Face during like a cyber benchmark. This kind of test things. So it just bypassed a lot of things. It was kind of scary, almost like from science fiction story or something. So just wondering, since we're talking about AI literacy, do you think it's imperative to include understanding AI's failure modes, security risks, not just how to use the tools?
Yeah. And that's one of the big reasons why I want, like, when you talk about, like, with AI literacy, I think it's really important that we understand what it's doing and how those kind of things happen. And so especially when you see like scary headlines about AI, I always, like, even I do this because I mean, I would say I'm an expert to a certain extent, but there are lots of things I don't know still. I have my narrow window of things of expertise. And so I often will try to find people that I trust who may know more about, say, in this case, like cybersecurity as it relates to AI. So I actually heard about the same, like I have the headline up about that that breach, and I found a video, and and it helps that I know about AI and how it works, and so it helps me to know who can I trust what this person is saying? Like, do they seem credible because I understand how it works? And so I will say for that, actually, the quote that I gave about AI can't code better than a human, it can code better than a human in an hour, is from one of these sources that I actually looked up about this particular breach. And they talk about the fact that um, it's not as scary as it sounds. So the headlines make it sound somewhat worse than it is. It's more for that particular one. I won't go into details because you could talk about it forever. But the security on OpenAI's side was like hacking out of it was not like they didn't contain it particularly well. It doesn't look like. And on Hugging Face's side, they had specific vulnerabilities because they run other people's code on their website that were not well protected from that point of view. And so um, yes, it hacked out, but also the protocol or the thing that they were doing with it at OpenAI was having it do hacking type prompts. Like they were having it see how well it could hack various things, and then it did this, final thing. So we don't know everything about it, but it's a little bit like if you know a little bit like more about AI and how it works and a little bit more about the situation, it's a little bit less frightening than it sounds. Um, Obviously, there are some who like there's the well-known book "If Anyone Builds It, Everyone Dies" about artificial superintelligence. And I do think some of the things they say are really interesting as far as and if everything lined up the way that they said it would, yes, you should be very concerned. But the chances of that, like what I see happening first is things like more often is what happened with ChatGPT. Like, yeah, it hacked into a thing, but it wasn't like, oh, it had its own ideas about what it wanted to do and went to Hugging Face and tried to get this thing. But it was an outgrowth of the things that we asked it to do. And so I'm not concerned. I think we don't need to be as concerned yet anyway about AI becoming like having its own things that it's trying to do. But we should be very concerned about the things that we're asking it to do. And I think we can see this a lot with people who are using AI agents to run their portfolios and try to build businesses, and which ultimately like run down their bank account. Like those are very like that is unwise. That is a foolish thing to do. And I do think it's like some of the things that ChatGPT, some of these companies, what they're doing is somewhat foolish, but I don't think it's society ending, although it may be costly.
Wow, that was really well reasoned. Thank you.
Okay, so we're running out of time, but thank you so much, Dr. Vasicek, for joining us today. This has been wonderful. We hope to have more Tethys Geoscience webinars in the future. If anybody wants to reach out to Dr. Vasicek, you can find her information at BYU in the linguistics department. And that is all for today. Thank you, everyone who joined.